I'm saying Kubernetes is different. I'm saying that it's a paradigm shift. And the reason I've baked this into an introductory talk is because this, like all the stuff I've just talked about with Minikube, this is an area when people first start using Kubernetes, it slows them down. And what I'm going to do is I'm going to give you two examples to try and explain why Kubernetes is different and how to think in terms of Kubernetes. And it also serves to sort of improve on the introduction to Kubernetes as well. So the first one I'm going to talk about is actually deploying onto Kubernetes. This is taken from the Kubernetes documentation as of Sunday, and it's what they call a Kubernetes object. You'll see people in blog posts sometimes call these manifests. There are other terms that kick around as well, but in the Kubernetes documentation, the official term for this is an object. It's nothing to do with object-oriented programming or anything like that. I guess they just didn't want to call it an entity. I'm guessing. I don't know. And what this says is we want 3 Nginx web servers running in a cluster. That's what that says. That's how you describe it in Kubernetes terms. Yes, it's YAML. If you don't like YAML, you will hate Kubernetes. You can work with JSON with Kubernetes, but because of the length of these objects, the JSON is horrible to read. It's quite easy for people to lose their way. So I let people try, and then when they screw things up, I say, well, try the YAML, and they go, oh yeah, that's a lot more readable, and they never go back to the JSON form for it. So my advice is stick with the YAML if you can. And what it's doing is it's telling Kubernetes what we want. We want a cluster of 3 Nginx web servers. That's what we want. And there's a CLI tool called CubeControl that we use to upload those objects to Kubernetes, sends it to the API. And what I'm going to do is I'm going to walk you through what happens when we run CubeControl, because it will help you see why Kubernetes is different. So CubeControl talks to the API on our control plane. That's what it does. And it sends over that YAML, more or less. And what the API does, it looks at what you've sent, makes sure it passes the schema or whatever validation it does, and then it writes it to the data store to say, okay, I've got a new object. And then the API also has an event stream that the controllers subscribe to, conceptually. There's a lot of implementation detail I'm deliberately glossing over here, but conceptually that's how it works. So the controllers get a message from the API saying, I've got a new object. It's of type deployment. Are you interested in it? Now, there's a whole bunch of these controllers, and most of them have never heard of a deployment and never want to hear of a deployment. But one of them does. So it takes this object and goes, I'll have a look at it. And it translates it into another object. That's what the controllers do. They look at the event stream and they react by creating, updating, and destroying objects. That's what they do. In this case, a deployment gets turned into something called a replica set. And the controller sends that back to the API, just like CubeControl does, and says, hello, have a new object. That's what it does. And the API goes through the same thing. It vets it and then writes it to the data store, and then puts it out in the event stream saying, hello, everybody, I've got a new replica set. Anyone interested in it? And this cycle goes round and round and round until one of the controllers eventually coughs up something called a pod. Or it updates a pod, or it deletes a pod. It's all CRUD operations. The controllers aren't running anything. They are literally creating, updating, and destroying data. That's what they do. And this happens at very high speed. And the reason it stops when you get to a pod is because a pod is actually the unit of deployment, not a container. A pod is a group of containers. It can have one container, but it can have more of them as well. I mentioned the networking earlier. Everything gets an IP address, but it's not containers that get IP addresses, it's the pod. So if you've got 3 containers in a single pod, and there are good reasons you'll sometimes put 3 containers in a pod, they get the same IP address. And that gives you a neat trick, because all of a sudden, let's say you deploy PHP and MySQL as a single pod. I wouldn't advise it, but it's something you can do. All of a sudden, PHP doesn't need to know where MySQL is hosted. It can just talk to it via localhost. And all that service discovery stuff disappears. just disappears. So for example, you might stick Memcache or Redis out there, for example, with your PHP, and you can do it. Now be aware, there is some this emulated networking and the kube proxy stuff that I've talked about before. It means that these connections may not necessarily perform as well as on a bare computer. I haven't got any figures either way to share with you, but sometimes the proxy gets involved in making these things look like they work seamlessly. And anytime the proxy gets involved, that will introduce at least some latency to your network operations. So if you're doing things at volume and scale, you'll need to benchmark it and decide whether you want stuff communicating via localhost or not. Just be aware of that. And when we get to a pod, the cycle breaks because the scheduler wakes up and go, pods, that's my bag, hands off. I'll deal with pods. And what the scheduler does, it looks at all the nodes and go, you're not very busy, I'm going to stick a pod on you. Sends an API request over to the pod, to the node and says, have this pod, make this pod happen for me. And the pod then talks to Docker or whatever runtime you're using there and says, start these containers for me, please. That's how Kubernetes works. And it's very different to how other infrastructure works. If you're used to managing traditional infrastructure, you're used to saying, deploy this, start this service, stop this service. There's none of that in Kubernetes. We are telling Kubernetes, we want these containers running. That's it. Kubernetes makes it happen. And one of the reasons Kubernetes does this, because it knows what we want, when things go wrong, Kubernetes can put it back, or at least it can bloody well have a good go at it. So if one of these, EC2 instances, they disappear. They stop running and they have to be replaced. So if all the containers that are on there, Kubernetes will just start up another VM for you and move the workload. If a container crashes, Kubernetes will start up a replacement. You don't have to intervene at all because you've told Kubernetes what you want in a way that Kubernetes knows it can keep it happening for you. So we've got these objects, and what they are doing is they describe something called desired state. You're saying to Kubernetes, I want you to look like this. Desired state. You'll see that phrase in the Kubernetes documentation. What Kubernetes does is it goes, once it's finished the whole thing with the controllers creating more objects, is it goes across the nodes and changes them to match what you've asked for. And we call that active state. It changes the active state until it's the same as desired state. So when something crashes, that means active state has changed, but desired state has stayed the same. So Kubernetes goes, oh, hang on, they're different. I need to put them back. And that's what it does. It makes it quite resilient. Hopefully all of you are programmers of some form. So you've dependency injection and containers like that. So you'd be familiar with inversion of control as a phrase. Kubernetes is kind of like that, but it's more an inversion of instruction. And when it's done right, and you don't fight Kubernetes, and you work with Kubernetes the way it wants to be worked with, the results is invisible infrastructure, as far as people who are running stuff on top of Kubernetes are concerned. You don't need to decide where something's going to run. You don't need to assign it IP addresses. It's all taken care of for you by Kubernetes. It's fantastic. You literally say, here's my app. It contains these containers. It exposes these ports and needs this storage and needs these load balancers. Kubernetes makes it all happen for you. The infrastructure becomes invisible. It's fantastic. Have you had that experience yourself with your Kubernetes cluster? Yeah. And how about yourself, sir?
It's a little bit different because we've got some services that only need to run in Australia at the moment that we just kind of started to get rid of a few problems with.
All right.
But
it's kind of an interesting story there.
Well, DevOps, they've been dealing with that issue more than I've been involved, so it's been a bit of a challenge at the moment.
Okay. Certainly, if you've got existing services and you're trying to lift and shift onto Kubernetes, it takes a while to adapt. And some of those problems is because containers aren't VMs. Now, anyone who's worked with Docker will have heard us talk about that before. It's only when you get to Kubernetes, though, that it really, really starts to hammer home. And hopefully you've already come to the conclusion that Kubernetes is nothing like managing a bunch of EC2 instances on Amazon, just from what I've said. That should be self-evident. But if you're used to using containers on local computers for development, I'm here to tell you that running containers on Kubernetes is nothing like that. But both the genius of Kubernetes and the bloody annoying frustration is they've deliberately made it look very close to that, so it's easy to get you started with Kubernetes. But going that extra mile and fully understanding it is what makes it hard. And especially for old timers like myself, old habits die hard. And you see people, when they come to Kubernetes, they're trying to make Kubernetes work the way they used to with infrastructure. Instead of actually, because it takes a while and it takes hands-on experience with Kubernetes to flip it round and realize how you've got to change to make the most of Kubernetes. And I'm going to give you a deep dive into an example about this. And we're going to talk about backups, especially with having talked about Minikube earlier. So I've picked a typical Java app. One process runs forever. It's not like what we used to do with our PHP architectures. And it's writing data out to a file system somewhere. And let's assume that this is binary data for the sake of it, because Java's a far faster language than PHP. Unfortunately, PHP is a slow language. It's great at what it does, but you start putting a lot of binary data through it and you'll realize how slow it is. Java doesn't have these problems. So they're more likely to be writing binary data to disk. This is typical stuff. You'll find this in back office systems like I work on up and down the land. Now on a traditional VM, to do a backup, essentially what normally happens is some form of someone SSHing into a box. This could all be automated in order to create an archive of the files on disk. Essentially that's what happens. Really dumbed down, there's normally that. It's either automated or in some cases people are still doing it by hand. If we switch over to Kubernetes and try and do that, can't do that. You can't SSH into pods at all, which means you can't create the archive of that file system. Can't do it. Containers and pods are black boxes. There are ways into them. I'm not going to teach you bad habits here and now. Maybe down the pub, but not right now. So you don't SSH into them to take backups. How many of you who run traditional infrastructure, VMs up on the cloud and stuff, and how do you do your backups? Yeah? Yes, you're making archives, yep. This takes that away from them. How many of you log into those virtual machines to update them, to patch the software on them? Yep. Yep. You don't do that with containers. They're immutable. You should treat them as immutable. You kill them and replace them. You deploy a new container. You don't log into them. You don't shell into them ever. Shouldn't be doing it. So that's the first thing that catches everyone who's used to traditional infrastructure. All of a sudden, the practices and experience you've built up stops working. You can't use it anymore. You've got to develop new tricks. Those of us who run containers locally for dev work, which I do, I love this. How I back up my dev stuff is I can get at these file systems from my host because I've mounted a host folder into the container. So I can take an archive off by, just from my terminal on my laptop. That's fantastic. I rely on that every day to do my job. But again, if we go over to pods, you can't get access to the host. You don't know which host the pod is on. There are ways to find out. Again, I'm not going to teach you bad habits. But you don't log into host to do stuff. And even if I did teach you how to find the host and go onto it, the host can't see the file system. It's not a file system on the host. It's attached storage from Amazon. It's an EBS volume, something like that. So you still can't do that archiving. And here's the other kicker. Only the container that's running has access to that file system. That's the only thing. That's the design constraint on all your processors. So that's the first problem. Now, I've picked Java not to diss on it at all. This isn't a PHP versus Java thing. But if you're putting Kubernetes into a shop that has more than just PHP, what happens on traditional infrastructure is typically someone logs into the box and stops the Java process first so that all its state that's in memory is flushed out to disk, so your backups are consistent. I don't know if you're aware of that, but with other languages and other technologies, some state's in memory and some of it's on disk, but any moment in time, the two may not agree. So you have to force a sync or a flush of some kind, and this is normally done by stopping the process or sending a signal to the process to tell it to dump its state. How it's done. It's been done like that for decades. Java's just doing it the way Unix systems have always done it. In PHP, we don't do this, you see, so that's why I'm not using PHP as the example. We stop the Java process, and then we know the files, if we back them up, that backup is going to will work when we have to restore it. Can't do that on Kubernetes, and I'll explain why. With the way most people design their containers, that Java process is going to be the main process inside that container. You stop that process, what happens? Your container stops, doesn't it? The whole container stops. And on Kubernetes goes, hang on a moment, active state has changed. What was that desired state again you told me 5 minutes ago? Oh yes, I need to start a new pod to replace the one that's crashed. And that can happen so quickly, there's no window of opportunity reliably for you to do anything with that file system in the meantime. Plus there's no running container for you to get access to it anyway. That desired state, active state stuff is such a game changer, but it also changes our processes. Kubernetes knows what it's supposed to look like at every moment in time because we've told it. So when something changes, like we try and stop a pod or anything to do backups and stuff, Kubernetes sees that as something it needs to intervene and put things back. And it's pretty good at doing that. It's not perfect, but it's pretty good at it. So all the tricks we've got for doing backups that we've built up over decades of experience with Unix-like operating systems, none of them work anymore, and you've got to come up with new ones. How do you guys do your backups?
I think DevOps are dealing with.
Your DevOps are dealing with that. There's no shame in that as an answer. Have you heard of rollouts on Kubernetes as one of its features? Okay. So when we tell Kubernetes what we want it to look like, we can also say how gradually we want that to happen. And it's called a rollout. And the nice thing about a rollout is you can actually change what a pod is doing while the pod is still running. You can tell it, switch one container for another, but don't trash the whole pod. Please keep the pod running. And what you can do is you can write your own containers to replace your app, and your container that new backup container can contain the code to back up the file system and upload it to S3 for you. That's how you do it. And then what you do is you then do a rollback once the backup's finished, and your container is back and live, and your app is back up and running. But in decades of running real infrastructure, I've never done that on a traditional system. Never done anything like that whatsoever. There are non-portable solutions to do with taking advantage of features of each of the cloud providers to do snapshots of file systems and things like that. But again, if your app's got state in memory and state on disk, and there's no easy way to tell it to flush without stopping the app, that doesn't always work. So this is the portable solution. But I mean, that took quite a lot of head scratching for us to come up with that one. So with Kubernetes, the answer to most of the problems is to make a specialist container to solve them. Not every problem, but it's the way it's going. So if you want to adopt Kubernetes as an organization, as a team, or as an individual, you need to be comfortable with knocking up your own containers to solve problems for things like specialist backups and stuff. If you are someone who only uses containers made by other people, or not just you personally, but as an organization, and you're not comfortable making your own containers, my advice is you are not ready for Kubernetes, unless you want to go all in to force everyone to learn these skills, of course. But with Kubernetes, because you've got desired state and active state, and the way that plays out, everything you know how to do on traditional infrastructure has to be revisited and reinvented. Every single thing you know. You are Alice through the looking glass. Everything is backwards, everything is upside down, everything is nonsensical at first, till you get used to it. I'll tell you what, I was doing a project at the minute where I had to go back to deploying onto traditional infrastructure. I talked them into putting Kubernetes on there. I missed Kubernetes badly. Once you're used to working with Kubernetes and saying, right, here's how writing desired state and uploading it, and it all just happening for you, having to go back to writing, download this file, copy it onto this machine, install this systemd script, write the bloody systemd script. God, I hate systemd. Start the thing, stop it for backups. It's just a pain. Once you're used to Kubernetes, it's you don't want to go back. You really don't. But it takes a while to get there. So that's what it's like to think in terms of Kubernetes. If you're trying to take your existing skills, your existing processes, and put them onto Kubernetes, you will fail. And you will hate Kubernetes badly for it. What do you think? Yeah? I'm not trying to put people off at all. What I'm trying to do is, if you're interested in Kubernetes but haven't yet got any hands-on experience, I'm trying to make sure you know what you're getting into. It's not something you just pick up and go with in 5 minutes at all, but it's worth the pain.